Hello viewers and welcome to a new STM32 World tutorial video. In this video we are going to elaborate on an earlier video, which is the one shown here, where we were talking about C pointers and variables. And we're going to elaborate further on a couple of issues that was in this video, as well as talking about how C is handling strings. So hang on for this video, and well, I hope you learn something from this video. In the previous video, this one, number 35, I got a comment that the only thing I can think of is that C programmers don't write and there. And what this viewer is referring to is this line that I put in the code, and he claims that this can be written, this can be simplified. Let's comment this out by simply making a reference to A. Let's try to run that. That is the second loop. So it's the one down here, and it works. So it is entirely possible to write this as this. I was actually aware of that, so it's not a surprise for me. I was quite deliberate about writing it this way to make it clear what was happening. As for the comment that C programmers, the reference for C, in my opinion, the C Bible is Kernighan and Rich's fantastic book, the NCC or C programming language. And on page 82 of this book, Brian Kernighan and Dennis Ritchie write PA equal, which is more or less exactly what I was doing in my example. However, if you browse further in this book, they do explain this down in pointers and arrays down here. They say that PA, same example again, can be written as this, and they explain why that is. So let me try to explain what is actually happening here. The thing is, an array does not really, it exists in C when you're talking about C syntax, but internally it is actually handled as pointers. So the A array here, A is actually not referring to any of the variable, but A itself is the address of the array, and that is why we can get away with this. Internally, C will actually reference elements in the area by doing pointer arithmetics, like what we're doing down here, where we're just moving the pointer up to the reference to the array, to the addresses of the array. Now, this leads to a couple of interesting observations, because if we look at the first one here, we are going through this array and referencing it with 0, 1, 2, 3, and 4. But we could quite easily write 10 plus up here, and then we're actually going through 15 elements. And let's see, and you can see it works perfectly fine. Now, since we are at this moment, we are only reading data, it's not really dangerous, but this illustrates one of the big dangers in C, that there is no internal checking of range in this array at all. So if we were writing to these, say A10, we would be writing to an undeclared array of area of the memory, and we could potentially overwrite something important and make the program crash or whatever. It's arrays can be dangerous, and it is up to the programmer to ensure that we are not going too far. I don't know if we can actually write a 10 equals 5 build project. See, there's absolutely no checking. We are way outside the defined array. So the index of an array is not checked in any way, shape, or form because it is just a start pointer with pointers adding up to the other elements. Same thing happens if you have a two-dimensional array. It just internally know how to handle the math of these pointers to actually reference the entire array. So in conclusion, I would claim that C programmers can write what I wrote up here because, well, Brian Kernighan and Dennis Ritchie is writing exactly that, but I agree that it is much faster, well, much cleaner. It looks much cleaner to do it this way. So yeah, I partly agree with this this comment. It's just less verbose, so that's how it is. So another comment on this same commenter on YouTube suggest I talk a little bit about strings. And I actually originally planned to do this, but as you know, I'm not scripting these videos. I'm just basically forming a rough idea in my head what I want to talk about, and then I move on talking about it. And I actually originally planned to talk about strings, but by the time I got around to that, the video was already too long. So let me talk briefly about strings in C. I'm not going to dive into this in detail, too much detail. I'm just going to show some examples of how to do strings in C. Now, I have included a couple of extra libraries up here. The most important is this, a string library. Now, it is interesting. We already kind of determined that that C, while it does have arrays, syntax-wise, internally just handle it as pointers, and pretty much the same thing goes with C. Strings. It does have some language features that lean towards strings, but internally strings are just an array, and therefore strings are just pointer math. So we have a possibility of defining. Let's define a couple of hard-coded strings here. So basically we say a C string 1, C string 2. This is a string. And then we can try to print out those strings. We can print out strings by just referencing %s in printf will print out these strings. So let's try to actually save this. Wait, build project. Let's try to do a breakpoint there and fire up the debugger and see what is actually going on here. So we fire up this and we look over here. So we'll see we have the variable which is this char array of 8 and 9. This one is 4, 5, 6, 7 strings long. So it is worth noticing that these arrays are 1 byte, exactly 1 byte longer than the string it contains. And the reason for that is that C basically contains, it's a character array, but it have the last element is a 0. So we're saying that strings in C is null terminated or 0 terminated, and that is how C detects that the string is has reached its end. So we can add this, and we can introduce another a function from the string library where we can say length equals %d, and that is the string. And we do the same down here. Len equals %d, and the string is that. And then we add here, we add the strlen c1, and down here we do strlen c str2. There. Let's try to run that instead. There. So we have a length is 7, this is, and the length of the string. So, in other words, remember it was, the array was 8 and 9, so the null termination, the 0 termination of the string is not counted as part of the string. It just indicates to C that the string has reached the end. So that was the first function from the C library, the string library, string header, string library of C. And these are standard functions. They are available on any C compiler in any C language. They are part of the standard library of C. So we can determine a length. We know that string is a character array, but there is when I mentioned there's some syntax support for strings in C is, of course, you can put a literal string in here, which is just a character array. So let's introduce a few more of those C library functions. First of all, let's create a buffer. A buffer we can play around with. So up here, before we introduce these strings, let's do this. So we make a character buffer of 128 hard-coded, all filled with zeros, and say the length of that buffer is, it should print out 128. And then down here we can introduce the first function, or the second, because we already did strlen, which is strcpy. It's copy a string from one location to the other. So if we put into sbuff, we put c string 1, then at this point in time, let's print out this sbuff down here. Where are we here? Let's print out this sbuff, and let's try to run this again. Let's try to run it without the debugger and see the output. It should just be this is sbuff is this is. Let's try to debug it. Let's try to single step debug this, and we go to our breakpoint here. We go to our breakpoint, and we can see that we initialized up here the sbuff with all zeros. So sbuff right now is all zeros, and then we can go down. We single step. Where are we? Here, function 6, and here, and you can see this was put in, and it's null terminated. Well, it already had nulls in there, so that is, I wonder if we can actually do, I wonder if this is legal. It will make it a little more obvious what is happening. Let's try that. There, sbuff. And oh, I need to step to our breakpoint. Nope, that was not possible. So we can only, okay, you can't fill the array with 255. There are other ways of doing that, but I'm not going to mess with that. The next function we can introduce is how to concatenate two strings, and we do that with a function called strcat, which take an existing string buffer and then add another string to that string buffer. Append, I should say, another string. So let's try to run this. And now we have the entire string. Why is that one? It's because it opens all this stuff. Never mind, we just move that up a bit. There we go. So now we have the complete string, except that we don't have a space because there was no space. So we could add another cat here. We can say strcat sbuff, and we can add a string literal space there and try to run that. And now we should have a space in there. So that is how the basic couple of string functions. I'm not going to dive into all the functions. If we look at this is actually interesting. If we look at the string header open declaration, you can see that there is a lot of functions doing all kinds of things with string. I will leave that for your pleasure to Google that. There is actually, I should point out, there is a Wikipedia article, Wikipedia strings in C string handling there, and that explains a lot of the functions that are available and how they are supposed to operate. It's a good starting point, as always. So there you go. Right. So as I mentioned, a string in C is essentially just a pointer to a character array. So let's elaborate on that a little bit down here. It is entirely possible to do a pointer. We could call that sbuff2, since we already have an sbuff, and just make that a pointer, and then we can allocate space for that on the heap, and we do that by saying sbuff2 equals malloc, and we can try to allocate 256 bytes for this, and then we need to check if we could actually get that memory. So something like if that one is not null, then we can do an strcpy sbuff2 sbuff. We can printf sbuff2 length equals d, and sbuff2 and sbuff2. Now, since we allocated this on the heap, when we're done using it, we need to free it again. That is not done automatically in C. So let's try to run this and see if that works. Didn't work. Must. We actually still have our bug up here. Let's remove that. Okay, I obviously didn't watch my last video. I forgot a new line here, so it worked all the time. So let's try to run this. There we go. The string is copied over, and so we are allocating memory for another buffer. We copy it over the sbuff into that, and we're printing it out, and we free the memory again. So that was 1, 2, 3 of the string functions in C. Now, it is very important to understand that C, as I mentioned, it makes no index check on arrays, so it is entirely possible. In this case, we have a length of 16, so if we try to malloc, say 10 byte, now it will probably still work, and that is the danger of this. It still works, but we now wrote into some memory when we did this. We wrote into some memory we had not reserved, we had not allocated, so we could potentially be overwriting something else. I wonder if we could actually do a sbuff2 sbuff3. Now I'm I'm just guessing that we might actually be writing into sbuff3. sbuff3. See, when we copy, we're actually changing the sbuff3, even though. So if we put a string into sbuff3, let's try to print that out. Sbuff3. Sbuff3, sbuff3, and let's try to run that. Yeah, we will have part of that string. No, we didn't. Length. Am I being stupid here? I'm not actually doing anything. Okay, it might not be allocated straight after the other. I don't know. I have to look into that. I'm sure somebody will comment below what actually is happening here. So anyway, we didn't free it. Free sbuff3. I'll leave it in here, and comment below if you know what is happening here. So now, just to introduce a few more of the C library functions we can define a new string literal here, which we say a string. Of course we want, and then we can try to find if they are matching. So let's check if two strings are matching each other. We have functions for that, which is called string compare. So we are comparing C string 1 with C string 3. So let's just try that and see what is happening. So C string 1 does not match C string 3, but it obviously matches C string 2 since this line is not printed. Now we can also search for a string in a string, and let's use the strings, or let's just play with it like this. We can do a string literal again. So we have string compare, which compare two strings, and it will return 0 if they match. Hence the first one is printed here because they do not match. So it returns something else. If it returns 0, we could down here, it's okay, you get my meaning. You also have a function called strstr, which searches for a string in another string, and it returns a pointer to that string in the first string. So if we are printing, we look at sbuff. Sbuff, as you may remember up here, contains the concatenation of these two strings. So if we search for as with a space, so between them, and then try to print that out. It will go from the AS and forward because it obviously have the... Now, I'm not going to dive into how you actually should handle this, but it is obvious from everything I've done here that strings and arrays are extremely dangerous for memory corruption and using. Now, all these functions have alternative functions which includes an n in the name, where you can actually limit what is happening. So if we go up here, you have these 3 lines. This is going to be a little bit ugly, but we could actually write them like this, where we use the strncopy, and then we calculate where we're going. And this is interesting because if we're looking now, if we try to run this, this is the beginning of the, so sbuff, this is a string. Now let's say sbuff, which was 128 byte long, was not long enough to hold this concatenation here. Let's say it was only, say, 12 characters. Let's try to run this. That's interesting, but this is a S. So basically we did not screw up the memory in this case because we only copied the first 12 bytes into this array. Anyway, as you can see from this video, it is messy and it is something you need to practice, and it is something you need to be aware of. There is no range checking in C. You can write as much as you like into these strings and it will just continue corrupting the memory. It is the responsibility of the programmer to actually make sure that you are not writing more into where are we now? entire string is copied because it's long enough. So let me remove this. This was just part of a thought process. We need this one to be long enough here as well, and let's remove that, and let's remove that. So this should be clean again. I saw a warning. Let's see what that is. Oh, we're not using it. It's just telling me I'm not using that one anymore. So let's not. There, warning was disappeared. So anyway, this was a very, very brief introduction to C strings and further elaboration into how C is actually handling pointers, and justification that my original syntax here is perfectly okay, and at least some C programmers will use this syntax, even though I completely agree that this one is much faster and perfectly legal, because A in itself is simply a pointer. When it is an array, it's a pointer to the first element, and further elements, when you index further elements, you are just adding to the pointer, as explained in the C programming language manual. I will strongly encourage you, to read section 5.3 in Kernighan Rich's Brian Kernighan and Dennis Rich's book, which you can find on the internet. I'm not going to link it because I think it's actually copyright protected. I don't know, but I suggest you just Google for it. There is a copy of it on GitHub somewhere. So Google for it, and you will find this, and check section 5.3 in this book, and try to understand. They have some great examples, and they explain a lot of this, and address arithmetic. Sorry, yes. English is not my native language, as you might have discovered by now. So that's it. That's all I plan to say today, and I hope that you learned something from this video. It was a little more messy than usual. This is not my strongest topic, and that's about it. As usual, please like and subscribe, and if you got anything out of this video, please comment below. Even if you didn't like it, please comment below. I read the comments, and as you can see from this video, I respond to the comments. So that's about it. As usual, enjoy the rest of your day. Oh, and it's Christmas, by the way. So let's see. It is actually the 24th today, so Christmas Eve coming up. Merry Christmas, everybody.